Hello everyone, we have an example problem here from Chapter 3 where we're given an information set about 20 used sedans in a car dealership's inventory. And from this information we are provided, we're going to find some summary measures. What is the, for lack of a better term, average price, age, and mileage of the cars in their inventory? How much variation is there in prices, in ages, and mileage on used cars from the inventory they have? And then lastly, we're going to figure out some correlation coefficients. How much does price get affected by both the age and the mileage of the car? So with the information that we have over here, let's look at the prices that we have, the ages that we have, and the miles that we have. We're going to try to summarize what is, on average, the price of a car that they have in their inventory. Well, we can use Excel to make that happen. We're given a list of the 20 prices for these 20 vehicles that are in inventory. I'm going to go over here to the cell to the right of the mean price of a used sedan, and I am going to use an Excel function to figure this out for me. You would add them up and then divide by how many there is. We'll have Excel do that quickly for us. Over here, this little f of x is the insert function button. If you click on it, you can type in all sorts of different things that you want, functions that you're going to use to do calculations from the information that's provided. The one that I want is called average. So I'm going to type in average, I'm going to hit go, and when I do, a bunch of average different functions come up. I want the first one, just regular old average over here. And if I hit OK, it's going to ask me to input the range of information that I want to find the average of. I want to find the average of prices. So if I wanted to, I could just highlight all of these numbers by clicking one and then holding down and letting go. But there's actually a better way to do this. If you have a properly compiled spreadsheet, which your template should be, you can go, let me delete that out, click on the first one until you get the circles that are around it, and then if you hold down Control, Shift, and hit down, it should highlight everything that's within the range. So what I'm trying to find here is the average of all the prices that we have from cell A2 down to A21, and now I'm going to hit OK, and it's going to tell me that on average, a used sedan in this car dealership's inventory goes for a price of $15,086.30. Let's find the mean age of the sedan using the same thing that we have before. I'm going to grab the average function, which is already highlighted down here, so I'm going to click on it. I'm going to hit OK, and the range I want now is all the ages of the sedans that they have, everything in column B. So I'm going to click on the first one that we have, Control Shift down, highlight all the information that's in there, and hit OK. And we come up with 5.05. So on average, a used sedan in their inventory is just a smidge over 5 years old. Once you use Excel enough, any spreadsheet software, you get real used to the functions that you have to use, so you don't have to always go and find them in the insert function button. You can if you want to, but you can also just type it in. I'm going to say this time by typing it in, this is equal to the average, open a parenthesis, of, we're looking for the mean mileage now, so all of the miles that we have. Click on the first one, Control Shift down, end the parenthesis, and hit Enter. And we come up with 45,810.05. The average vehicle in here has just under 46,000 miles on it already at the time that it's being sold. So we have a bit of information here about the average, what the middle point is of all the different prices and ages and mileages respectively. Let's check out if there's any grand variance in here. Is there a big difference between the prices? Like, 15,000 is the average, but you could have some that are way above and some that are way below, or are they all very tight to that $15,000 point? Well, to do that, I'm going to have to find another function that finds the standard deviation of this sample of 20 used cars that we have. And if I go up to insert function over here and I type in stdev and hit go, short for standard deviation, it gives me an entire list of things over here. A lot of different ways that we can go about doing standard deviation. Some of these, like this base one I have right here, stdev, it says down here are compatible with 2007 and earlier. I don't know why Excel keeps all these old functions in here, but they're no good for us because we're using a version that's much newer than that. So ignore anything that says Excel 2007 and earlier. Anything that ends with a .p means of a population. We don't have a population here. This isn't all cars in this company's inventory. It's just a sample of 20 used sedans. So we don't want the standard deviation of a population. Anything that has an A in it, we'll use what they call a logical argument. You'll look for some qualitative variable in there. Is it red or is it not red? Something along those lines. Well, we're not messing around with any of that. Everything we have is expressed in numbers. So we have a sample that is just represented in quantitative data, which means what I want is stdev.s, standard deviation based upon a sample. I'm going to hit OK. And when I do that, I'm going to pick the range of numbers I'm trying to find the standard deviation of. I'm on the used sedan prices, so I'm going to click on the first one, Control Shift down, highlight cells A2 to A21, and hit OK. And I find out that the standard deviation in the price of used sedans is $3,560 and some change. Well, what does that mean? Standard deviation is a normalized measure of variance, a measure of spread that they have in here. And on a baseline, what it means is that 2/3 of the cars that they have in inventory are within one standard deviation below or above the mean. So we know that our mean is, I'm just going to round off to approximate here, about $15,000. And our standard deviation is about $3,500. So 2/3 of the inventory that this car has would be between one standard deviation below, 15,000 minus 3,500 is 11,500, or one standard deviation above, 15,000 plus 3,500 is 18,500. So 2/3 of their inventory is somewhere between 11,500 and 18,500. Let's do the same thing with age over here. I'm going to go back up. I'm going to grab my standard deviation.s function one more time. Now I'm looking for all the different ages that we have in inventory, so I'm going to highlight this entire range, B2 to B21, and I'm going to hit OK, and I come up with 2.68 years. Same concept applies. 2/3 of the inventory that they have will exist within one standard deviation below or above the mean. So 2/3 of their inventory is somewhere between about 2.5 years old and about 7.5 years old. And then lastly, the standard deviation of the used mileage. Again, if you want to, you can just type in over here. This is equal to the standard deviation.s. Open a parenthesis of all of the mileages that we have in our sample, C2 to C21. Close that parenthesis, hit enter, and I come up with 22,642.97. So 2/3 of the inventory is somewhere between 22,600, close to, below the mean mileage of 45,810, or 22,000 miles more than the mean mileage of 45,810. So we have some information going on over here. We know about the central point of the price, age, and mileage of all of their used sedans, and we know that price has a okay level of variance to it. Everything's kind of close to 15,000. There's a range, pretty decent range of age in here, and there's also a pretty decent range of mileage. What we don't know right now is what causes this change. I mean, what causes a change to the price that a company, this dealership, can charge for the cars that they're selling out of inventory. That is the correlation between the two factors. So let's figure out what the correlation is between price and age. And to do so, I'm going to use the correl function. Type in C-O-R-E-L, I'm going to hit go, and it's going to be the first thing that pops up over here. And I am asked for array 1 and array 2. When you fill this in, what you're always looking for is what is causing the other thing to change. In this case, we're trying to figure out how does age change price. Well, for the price, that's the response variable, if you will, that we are looking for, and we want to put that into array 1. So array 1 should be the thing that you're looking for the change in. So I'm going to click all of the prices that we have. For array 2, it is the dependent variable, or the explanatory variable, the thing that explains the change. In this case, the age should explain the change in price because older cars sell for less than newer cars. So the array that I want here is the entirety of the information that we have about age, B2 to B21. And when I click OK, I come up with negative 0.911. So what does that mean? Well, for a correlation coefficient, the closer that number is to 1 or -1, the stronger the relationship is. This is 0.9 is pretty close to -1, which means there's a very strong relationship between the two. As age goes up, price goes down, and that makes sense. If you think about it, every used car, the older that it is, the less you're going to be able to charge for it. So we know that age is a very contributing factor to the price that you can sell a car for. What about the amount of mileage that's on the car? Well, we can use the same function again. Going back to the Corel function over here, I'm going to hit OK. Array 1 is still going to be the output we're looking for, the response variable, so all of our prices that we have. But now array 2, we're seeing how mileage affects that price. So I want to have all of the miles. And I hit OK on that after I put in all the values in column C into my second array. And I come up with negative 0.759. Not as strong as age. So the information that we have here, if we are working at this dealership and we're trying to set prices, is that the age of a car actually lowers its price worse than the mileage. An older car that's not high mileage will sell for less than a newer car that doesn't have as much miles on it.